Hello everyone. In this course, we will continue learning IoT industry applications and solutions. In this section, I will introduce the solutions for the IoV and industrial IoT scenarios. First, let's look at the IoV scenario. In this part, we will introduce the IoV and DRRS solution. Although vehicles bring us a lot of convenience, the automotive industry has a number of major problems that needed to be solved by IoV. First, it has safety problems. These are very common. For example, some drivers ignore lights flashing on their dashboards, disregarding the risks. In this case, a technology is required to upload the information as soon as possible, analyze the information, and then contact a vehicle repair company for repair. Similarly, vehicles are mainly driven manually. In foggy weather, low visibility makes driving dangerous. If a technology can help the drivers identify road situations and drive cars automatically, driving experience will be greatly improved. Second, the automotive industry has efficiency problems. Low efficiency is mainly caused by insufficient information exchange between vehicles and their surrounding environments. Drivers cannot respond quickly enough in situations such as speeding and traffic jams. In addition, there are multimedia problems. Take listening to music as an example. Nowadays, we prefer listening to music in vehicles by connecting them to mobile phones using Bluetooth, rather than inserting CDs and memory cards. However, this method is not convenient enough, as the vehicles cannot provide multimedia information by themselves. There are also some value-added services, such as insurance. The traditional vehicle insurance pricing model is based on vehicles. That is, calculating your premiums based on the number of claims you had made. But this mode is unreasonable. There is usually only a small difference between the premiums of people with good driving habits and those with bad driving habits. Vehicle insurance premiums should be calculated based on drivers instead of vehicles. The premiums should be determined based on people's driving habits. The technology that can solve the preceding problems is the IoV. So what is IoV? IoV is short for Internet of Vehicles. It uses in-vehicle devices and wireless communications technologies to utilize all vehicle information on the information network platform and implement different functions. In the sentence above, we can see that IoV is part of IoT. First, it has in-vehicle devices at the sensing layer. In addition, it uses wireless communications technologies to transmit vehicle data to the platform for analysis. The platform involves other data for collaborative use and provides the data to applications. In addition, the IoV has other features. Vehicles in the IoV are intelligent and can control the distances between them and other vehicles to reduce accidents, regardless of whether other vehicles are intelligent or not. Vehicles in the IoV can communicate with each other to improve traffic efficiency. When discussing the IoV, we have to mention V2X, which is also called the Vehicle Road Cooperation Solution. It integrates digital technologies such as cloud, IoT, artificial intelligence, and 5G to implement efficient coordination between pedestrians, vehicles, roads, and clouds. A vehicle is regarded as a device like a mobile phone or a computer. It senses all things on the road, including other vehicles, pedestrians, roadside infrastructure, and networks for information exchange. That is V2V, V2P, V2I, and V2N. In addition to the V2X, another concept that I want to share with you is Digital Road Infrastructure Service, which is DRRS, which is one of the Huawei's IoT services in the automotive industry. DRRS focuses on the variety of roadside devices. DRRS includes services on the cloud side and the edge side. DRRS on the cloud side provides data analysis and collaboration with the edge side on the cloud platform. DRRS on the edge side provides real-time service processing capabilities related to edge computing, such as sensor data access and road event identification. The goal of DRRS is to connect multiple roadside sensors to implement digital sensing of roads and provide useful traffic information to traffic participants. Now that we understand Huawei's IoV solution, let's see how the IoV develops. The development of the IoV is divided into 3 phases. The first phase is to meet the requirements of entertainment and navigation. In the phase, vehicles are connected to the internet, so drivers can listen to music online and obtain road information. The navigation system can update road information in real time. In the second phase, we pay more attention to vehicle status and collect information such as fault detection, fuel consumption, and mileage. In the third phase, we can analyze surrounding environment information through sensors installed on vehicles to achieve automated driving. Currently, the development of the IoV industry is in the second phase and is moving towards the third phase. Vehicle services mainly include origin equipment manufacturing, which is OEM, and aftermarket services. OEM services include safety facilities and entertainment devices before delivery. Aftermarket services include auxiliary measures and devices such as insurance, smart rear-view mirrors, and in-vehicle Wi-Fi. Now, let's move on to several typical applications or devices in the IoV. The first one is head-up display, which is HUD. Its purpose is to make driving safer, even if you are using in-vehicle navigation or mobile phone navigation. You still need to move your head or look down when viewing the navigation system. This is a safety risk, as it can interfere with your ability to respond to sudden changes on the road. HUD can help us view the navigation system and the road at the same time. We do not need to move our head down to look at the navigation system, but because windshields on vehicle aren't mirrors and the light is reflected on them. Current HUD systems are not very clear. HUD is therefore not popular yet. An onboard diagnostics, which is OBD or T-box, is a small gateway applicable to vehicles. It collects the data detected by in-vehicle sensors. After collecting the data, it uploads the data to the cloud platform and displays the data to users or to insurance companies for driving behavior analysis. UBI is a new type of vehicle insurance in the IoV. UBI is short for usage-based insurance. In the vehicle insurance field, UBI determines premiums based on usage. Premiums are calculated based on driving habits of drivers. First, it analyzes drivers' driving habits based on the data uploaded by the IoV and classifies them into 4 categories: high risk and poor behavior, neutral behavior, and high value. Then it sets specific premiums for drivers based on how they score in these categories. UBI is fairer than traditional insurance services. UBI can also encourage drivers to improve their driving behavior through scoring and other methods. In addition, there are a series of automatic toll collection services. These services are more efficient than the electronic toll collection that we are currently using. ETC requires drivers to wait at toll gates for a short period of time, whereas automatic toll collection is automatically performed based on vehicle driving tracks. There may be no toll stations after automatic toll collection becomes commonplace. GPS positioning and GRS systems are used to determine driving tracks of vehicles and determine vehicle tolls, which makes our travel more convenient. That's all for the IoV. Now, let's move on to the industrial IoT scenario. The industrial scenario is always important in the IoT because a large number of products need to be manufactured. Improving the efficiency of industrial manufacturing becomes particularly important. Therefore, it is an inevitability that IoT technology will be applied in manufacturing to improve efficiency and accelerate the development of the IoT. Industry 4.0 is the fourth industrial revolution we talked about in our introduction to the development history of the IoT. We are now in the middle of a new industrial revolution. The first industrial revolution, represented by the steam engine, brought great change to our lives. The second industrial revolution witnessed the wide application of electric power. The automation brought by the third industrial revolution has greatly improved efficiency of manufacturing. A large number of digital technologies have become the foundation of the fourth industrial revolution. We need to make all devices intelligent and connect all devices to further improve manufacturing efficiency. However, we have encountered some bottlenecks. All we can do is to automate the production and manufacturing process. Our goal is to be fully connected. That is to connect people, data, and machines. When we shift our focus from production automation to full connectivity, that we need to do is to make manufacturing more efficient, refined, and intelligent. Therefore, we need to collect all vertical production information from devices at the sensing layer, such as machine tools and mechanical arms, to communication devices. All the device data can be used, so all the devices can be centrally managed. In addition, we need to integrate different industries. Although there are many different applications in the upper layer industries, the devices used at the sensing layer in the industrial field may be similar. Therefore, we can integrate these devices to implement comprehensive connections between people, data, and machines. We will begin with the collection of data used by the devices to construct the production IoT. We will use the cloud platform and big data analytics to build an industrial IoT featuring device cloud synergy. After that, we will make O&M data on the cloud platform movable so that O&M personnel can know the production status of devices in the factory anytime and anywhere, thereby connecting all things in the industrial IoT ecosystem. How can we achieve full connectivity? We need to use various emerging ICT technologies. First, we need to make the devices at the sensing layer intelligent. Devices using multiple different communications protocols can be connected and communicate with each other, thereby achieving collaborative operation between them. In addition, networks need to meet the requirements of connections in large quantities and in different scenarios. In the same industrial scenario, devices in different environments or in different applications have different requirements for networks. For example, when we control precision mechanical devices, we need networks with low latency and high reliability. For video surveillance applications, networks must provide high bandwidth. For metering applications, the network rate can be low and the network cost must be low. All these devices are used in the same industrial scenario. Therefore, we hope that networks can connect all these devices. After the requirements of devices and networks are met, we need to process the collected data to maximize data value. In this way, we can achieve intelligent coordination and linkage between devices and full connectivity. Based on the preceding ICT technologies, Huawei has designed the following industrial IoT solution. Like IoT solutions of other domains, the industrial IoT solution is also divided into 4 layers. At the sensing layer, there are various devices used in the industrial field. At the network layer, we use wired and wireless access modes, such as Ethernet or industrial IoT gateways. Most devices in the industrial field are huge and cannot be moved. Therefore, wired connections are used to ensure the stability of data transmission. We will gradually start using wireless connections to make the industrial IoT more flexible. The platform layer provides capabilities such as device access, device management, and device data processing. It analyzes the data collected by devices and transfers the processing results to various applications at the application layer for display. Now that we have an understanding of the industrial IoT solution, I'd like to show you some of its typical applications. The first is production visualization, which is important in the industrial IoT. Production visualization means that data collected by the platform is displayed in graphics or other easy-to-understand modes. It can convert the data into a production management, execution process, and decision-making basis that are easy to understand. For industries, production visualization can improve the production reliability of factories and help enterprises better control equipment in the production process, thereby allowing factories and enterprises to control costs more easily. In addition, it provides valuable experience capital for product update, iteration, and development. For plant managers and decision makers, production visualization is a comprehensive decision-making tool that helps them better understand where problems occur, increase production output, and reduce costs. We can see that different parts in industrial production applications, for example, process flow, process operation efficiency, and production data sorting, can be presented in the visualized manner. The second application we will look at is asset locating. Asset locating is a common application in campus and industrial scenarios, because warehouses are used to store assets in campus and industrial scenarios. It's important to make the best use of everyday item in the warehouse. We need to be able to locate the items easily and know their validity periods. That's where asset locating and tracking comes in. Asset locating can be used in campuses and industrial scenarios to help managers locate the assets that need to be used. In industrial scenarios, all transport vehicles or machine tools can also be located. The location of a transport vehicle can be displayed on the platform, and the shortest transport path can be planned for the transport vehicle. Some industrial valuables also need to be located. When these valuables are taken out of center areas, the platform can report alarms to supervisors. How do we perform locating and tracking? First, we attach tags to all objects to locate it. These tags contain wireless communication chips. Positioning base stations send signals to the tags to determine the locations of the objects. In addition, different devices are classified into the high precision positioning scenario and low precision positioning scenario according to their application scenarios. For example, devices that don't need to be moved frequently adopt low precision positioning, and devices that often need to be moved adopt high precision positioning. The location information is reported to the IoT platform and used in various applications, such as optimization of production resource usage. That's all for the IoV and industrial IoT scenarios. In the next section, I will introduce the development trends of IoT technology based on other emerging technologies. Thanks for your watching. See you next section.